Hello. Have you ever wondered what's inside a telescope eyepiece? Well, let's take a couple of them apart. This one here is a Kellner eyepiece. We're going to open this up, take a look at the lens elements, and I have another one, a Reverse Kellner. We're going to do the same. Open them up, let's compare the optics inside, see how it looks. We'll of course use a screwdriver to open up the ring there. That's the retaining ring, so I have a screwdriver to take care of that. Here we go. That's a joke. Yes, that's a joke. So what's inside a telescope eyepiece? Well, different eyepieces have different lens configurations, but in this video we're going to be looking at Kellner eyepieces. This is a 25mm Kellner. They call it a wide angle eyepiece, but it's really not. It's kind of narrow angle. I mean, I just get the impression it's not that wide. Okay, so here we are. We've got our eyepieces we're going to be looking at. These are both Kellner eyepieces. I mean, different eyepieces have different lens configurations, but these will be Kellners in one form or another. And I say that because while this one is marked as a standard 25mm Kellner eyepiece, this one's a little bit different. Get this in the light. It's a 20mm RK eyepiece. Now the RK there is interesting because that's a designation of a reverse Kellner. Well, I don't know. Are the lenses backwards in here? What's the story with this one? Well, I'm not sure. And we're going to find out, but we're going to start by taking apart the standard Kellner. I pretty much know what's going to be in here, but let's look. I've never opened this particular eyepiece. I have opened up another Kellner up, but this will be the first time. So here is the this is the part of the barrel that goes into the diagonal, star diagonal or eyepiece holder, and that groove that you see, this cut in on the barrel, that is so that there's a grip surface here. If you put this on your telescope and you tighten down the clamps and the star diagonal, there's a couple of screws. You tighten those down and they'll tighten down into this little undercut, and that will, if those lens screws loosen, they won't loosen enough that they'll come loose. The undercut in here will hold your eyepiece in place, so that's a safety thing. Some eyepieces have it, some do not. But anyway, here is the business end of this guy. Looking at it, it's single coated. This is not a multi-coated eyepiece. It's a single coating. If I'm correct, all the guts are held in by this little collar. And we're going to go at this, loosen this up. Being careful not to touch the optics. Try to bust this loose. There we go. Alright, it took a couple of tries, but we have this lock ring loosened now. Now I can remove this. I was being very careful on Trying not to have the screwdriver slip because there's glass in there, of course, optical glass, and I didn't want to damage that. So once this lock ring comes out, we should be able to get at the contents of this eyepiece. Now this says a Kellner KE 25mm wide angle eyepiece. I don't think it's particularly wide angle. I don't get that impression when I'm looking through it. But here we go. Something's coming out. It's all coming out. Okay, alright. We've got glass. Alright, we got more glass. There we are. Okay, here is an empty barrel. And the anti-reflection coating in here is, get it so your camera can see it. Get some light reflecting on it. It's not real dark anti-reflection. There's a little bit of a sheen on here. It's not too bad, but I would like to see it being a flatter black than that. But get that in the camera angle in the corner. Okay, here is the eye lens. This is the eyepiece side. And if you notice, it looks like it's a doublet. And it's a cemented doublet. These are cemented together. We've got a convex surface on this side. On this side it's flat. So that's this is the eye lens portion. And this is the standard build for a Kellner eyepiece. The eye lens is actually a doublet. And there'll be one more piece of glass in the back. I'm going to sit this on a microfiber cloth. I don't want to sit this on this towel. This towel is obviously to prevent it from rolling away and try to keep it from getting bumped. But I don't want to sit that piece of glass on the surface of this towel. So here's the lens that's part of our eyepiece. We'll leave it here. Alright, with a spacer. Here's the field lens. Now to take a look at this field lens. It's flat on the side facing the telescope. So the telescope basically is in this direction. Maybe, you know, if this is on a star diagonal while you're looking down towards the diagonal's prism or the mirror, and then the telescope is this way on a 90 degree or a 45 degree, whatever your diagonal is. But we've got that flat side and we have a curved side. So inside a Kellner eyepiece, the two curved surfaces face each other like this. I hope you can see that. We've got two curved faces of these lenses facing each other. Kellner is a old design. I mean, there are older designs of eyepieces. There's Huygens lenses, a Huygens lens arrangement. There is a there's another one that escapes my my thinking at the moment, but I'll get my notes in front of me. Those go back way far, but Kellner eyepieces were invented in the 1800s. I believe the man's name was Carl Kellner. I'm going to look that up and clarify that later in this. video, but that dates to the mid 1800s, and actually Kellner eyepieces were still in use pretty extensively up until at least the early 1980s. So it was a design that stands the test of time. They're still around, but they've been replaced by Plossils. Plossils give better performance than this. But these are actually very good. They were no slouch. It's just that they're better. These eyepieces, though, the reason they're still around is they work pretty well in Cassegrain telescopes. Schmidt Cassegrains and Maxitov Cassegrain telescopes that have long focal lengths, like f10, f11, f12, which is typical for that type of telescope. These work pretty good in that kind of a scope. And they're relatively cheap too, so they're bargains. So these are no slouch. Now, we're going to set this aside. But I want to set them aside in a way that I remember how to put it all back together. These spacers, we'll leave this slightly off camera for the moment. And let's take a look at the Reverse Kellner, because I'm really curious about that. A Reverse Kellner? Are the lenses in backwards? I don't know. It can't be just simply these reversed, because if you took a Kellner eyepiece and turned these lens elements around and put them in the other way, if you actually reversed these elements and swapped them, it's not going to work. So that's not what a Reverse Kellner is. So we open up this guy. And now the same way, this screwdriver has to go back into these slots, but I have to be real careful on this because I don't have the wall of the eyepiece barrel to lean against. So let's get this loose. There we go. Okay, that came loose a little bit easier than this one did, which is good because, as I say, I was a little bit nervous about that. All right. Okay, so here's the differences. Here's a lock nut. Here's a lock nut. Now there we go. Everything just dropped. Everything just dropped. Uh-oh. And everything just spilled. All right, here's the Reverse Kellner. Okay, look at that. It is kind of a reversal of this original eyepiece. Remember, on this eyepiece, the doublet was the eye lens. On this Reverse Kellner, the eye lens is actually a single piece of glass. The field lens, and this is the part that faces the telescope, it's called the field lens. This is the doublet. But notice it's a let's get this so you can see it. It's a stronger curve on this side. This side is flat. This side is a stronger, deeper curve. It's more domed. And these lenses, it's a cemented. Sorry for the glitch. My camera made a hiccup here while I was in the middle of this. But anyway, we were discussing the difference with the Kellner eyepiece versus the reverse Kellner. Notice that it's not just reversing the Kellner eyepiece lens elements around. This one's actually a little bit thicker than was the other eyepiece. So they're really almost, to take this apart and take a look, they're almost the same, except that this one is domed and this one is flat. So the optical formula is a little bit different. It's a little bit different optical formula. But it sure does the job. But yeah, so this is the interior of a reverse Kellner. This is more domed. This convex lens, notice how much more domed it is than the other one, the other Kellner. And of course, this eye lens also, get it where you can see it. It's more of a domed shape. But the domed areas on a Kellner, the original Kellner and this one, the domed surfaces face each other. And the flat surfaces, one faces your eyeball on this side. That's where your eyeball goes. On this flat side, this is the side that's ultimately going towards the telescope. And the domed sides face each other internally with the scope. So anyway, yeah, this is educational. And it's different. I enjoy taking this apart. Now, I enjoy taking stuff apart. I like to see what's in it. If you don't have the confidence to tear into something, don't do it. With this, I've taken other eyepieces apart, so I kind of knew what I was going to expect to see, but I was real curious the difference between a Kellner eyepiece and a reverse Kellner eyepiece. And so this is how it is. Does it make any difference at the scope? I don't know. I don't see any difference. But we're going to get these back together now, and I'm going to work on that off camera. I'm going to be using lens tissue. I'm going to be using this microfiber cloth, and I'm going to be using a lot of caution. It's going to take a lot longer to put this back together and do it carefully than it did when I took it apart. So I'll come back when we're getting close to getting it finished, or when it's finished and we can look at it. So here's a progress report. I've got the lens elements back in this reverse Kellner. I used, of course, everything was worked on this microfiber towel, this microfiber surface, and I used this piece of lens tissue to actually handle the elements, to get them back in here and get them back in the appropriate orientation. And then I snugged down this lock ring, first by hand, and then use the screwdriver to just get it in snugged up. I'm doing this so you don't have to. So yeah, don't do this at home, folks, unless you're just willing to take a big chance, because you have to be meticulous and putting it all back together. But in this instance, you got to see what a reverse Kellner lens looked like on the inside, and you can see the tint of the coating when I hold the eyepiece here a certain way. Get it over here so you can get the light on it, and you can see that optical coatings here, the reflecting. So this, you know, it's a nice lens. This is a nice eyepiece. See, we get the coatings here again. So anyway, this is the RK lens, and it's back together. And I'm going to work on the standard Kellner here, and I'll report back as soon as I get that together. I don't want to bore you guys with watching this because it takes a while. It's harder to put something together than it is to take it apart. Also, I have to worry about dust getting in between the optical surfaces, so I'm using a lot of canned air here to make sure everything is blown off, but I have to do it carefully and gently because I don't want to send these optical elements flying off this table, because boy, that would undo all the careful work I did. So as I say, this is not something you want to do casually. If you want to do it, go ahead, but I say just look at what I'm doing and call that a day. Get outside and enjoy your eyepieces intact. So here's the Kellner eyepiece back together. I use the screwdriver just give this a little tweak, that lock ring, make sure it's tight. Now I put these back together. I can assure you that when you buy an eyepiece, if you buy it new or you buy it used, if you shake it, there should be no rattling. There wouldn't be. If it's new, it rattles, it's defective. You buy a new eyepiece, right out of the box, you shake it, and there's a rattle, something's not right. Send it back. In something like this, I took the eyepiece apart, I put it back together. That's my test. I shake it. If it doesn't rattle, that means everything's in the way it should be. This thread's back on. I run this is a precision thread, so I run it backwards until I hear a click. There you go, the threads have engaged. There it is. Now I go forward, and I'm not going to cross thread anything. Okay, so the Kellner lens is back together. The reverse Kellner lens, this RK lens, is back together. See the RK, there we are, the RK designation. So this is back together, and again, no noise. There we are, RK, 20 millimeter. There. No noise. Okay, so both of these are back together again, and they work. And I checked my notes. The Kellner eyepiece was invented by Carl Kellner. This eyepiece was designed and first fabricated in the year 1849, and I've looked this up on Wikipedia and a couple of other sources, and yeah, that 1849 date it's verified, so it's been around that long. So this is a very, very old eyepiece design, but it works. And as I say this, I find that these work pretty good with Cassegrain telescopes, particularly Maxitov Cassegrains, because their focal ratios on those telescopes are usually f12, f13, some go up to f15. So that long focal length scope, the light rays are bending, they curve in, the mirrors are curving the light rays in, not aggressively but very gently. And this eyepiece works well with them, and as I say, they're pretty cheap. So if you have a Maxitov Cassegrain scope, these are a good match for that. If you have a Schmidt Cassegrain, typically like a Celestron, telescope, a C5 or a C8, these will also work pretty well. They'd be a really good match for Celestron's small scope, the C90, which is a Cassegrain, a Maksutov Cassegrain. And we're going to talk about the differences between Schmidt Cassegrains and Maksutov Cassegrains in another segment. But these eyepieces been around since the mid-19th century. So here we are in the 21st century, and they're still quite useful. I would not use these in a reflecting telescope that's like f4 or f5, where the focal ratio is really short. They're not going to work well. I guarantee this would not work well. Same way with a refractor that has a short focal length, like a f5 or f6 refractor, f7. I wouldn't use these. But if you have a refractor that's focal ratio f10, f12, f13, this would also work pretty decent with it, as long as the light rays are being bent very gently towards the focal plane. These are going to be good. All right, so that takes care of this this segment. You got a chance to see what's inside an eyepiece. As I say, if you opened up a Plössl, they're called symmetrical eyepieces, you would find 4 lenses in 2 groups of 2, and most likely they'd be identical, but you still wouldn't want to switch them around because there's probably a little bit of difference between the field lens group and the eye lens group. So use your eyepieces. Don't take them apart unless you're taking the risk that if you don't mind destroying it, well, whatever. But I'm saying don't do what I do. Do as I say, not as I do, and have fun with your telescope. I took these apart so you could look inside and you didn't have to feel like you have to do it. If you ever thought like, do I want to take this apart? Well, you saw me do it, so you know what's in there. All right, well, until next time, I'm going to say have a good day. If the skies are clear tonight, go out with binoculars or telescope, look up, and enjoy what you see.